Okay, hello everyone. Good morning to all of you. In this video, we are going to discuss some numericals belongs to different distributions, different discrete distributions. This question belongs to binomial distribution. These two questions belongs to Poisson distribution. These two questions belongs to geometrical distribution, and these two are belongs to negative binomial distribution, and this question belongs to hypergeometric distribution, and this question belongs to multinomial distribution. Basically, we have been studied these six discrete distributions, that is your binomial distribution, Poisson distribution, geometrical distribution, negative binomial distribution, hypergeometric, and multinomial distribution in our syllabus. Okay. So problem where we are facing that whenever we are getting the question in our exam, in the exam we are somewhat confused, or we can confuse that the question is belongs to which distribution. If we can identify, suppose in our exam one question has been asked, and if we can identify easily that this question is belongs to this distribution, one of this distribution, then we can easily apply the PMF, probability mass function, for that corresponding distribution, and we can easily solve that problem. For that purposes, or how we are going to identify easily the question is belongs to which distribution, the video, this video I am doing for you. You just watch it carefully. If you want, you can write down in your note. Okay. So I suggest one thing to you, that before you have to attempt one question, carefully you have to study or read that question uh, 2 or 3 times. So whenever you are going to read that question 2 or 3 times, automatically you can identify that question is belongs to which distribution, right? Here is the first question, that 10 coins thrown simultaneously, find the probability of getting 7 heads. Okay. As per this question, 10 coins is going to be tossed, or you can say one coin tossed 10 times. So we are going to get the sample space, or the sample points of the corresponding sample space will be equal to 2 to the power 10. Okay, if one coin is going to be tossed one time, then the sample points in the sample space will be 2 to the power 1. If that one coin is going to toss 2 times, the sample points in the sample space will be 2 to the 2. So here 10 coins has been tossed one time, or you can say one coin tossed 10 times. The sample points in the sample space will be 2 to the power 10. Okay, now here in the question it has been asked that what is the probability of getting 7 heads. 7 heads. So in this question, if we are going to go for the traditional way, we have to find out 2 to the 10 means around how much, 1024 sample points we have to find out. Then we are going to search how many sample points belongs to your 7 heads. Okay, so if we are going to go with traditional way for this question, it will be take so long time. So here we can say, or we can see here that for getting one head, what will the probability? 1 by 2, right? In the question it is asked that 7 heads, we have to find out the 7 heads. So here the probability of getting one head equal to P equal to 1 by 2, and the number of trials, you can say number of trials N equal to your 10. That means one coin tossed 10 times. Okay. So here you can see that the probability is 1 by 2 or 0.5, quite large, and n is equal to 10, quite small value. The number of trial is 10, so it will be go for the binomial distribution. So how this not to be accepted for the binomial distribution? Whenever the probability will be very less, suppose probability we are going to get 0.01, and the number of trial, some question we are going to get more than 1000, then for this type of question we are going to accept, or we are going to consider for the Poisson distribution, whatever we are going to discuss here. Okay, so for this question we accepted that this is belongs to binomial distribution, where the probability getting head equal to 1 by 2, and q belongs to probability getting tail, also 1 by 2. Now the probability for getting x heads according to binomial distribution, probability for getting x heads, that is your this one, px equal to ncx p to the power x into q to the power n minus x. This is the PMF of binomial distribution, probability mass function, this one for the binomial distribution for x getting x head. So here in the question we need to find out 7 heads. So n is your 10, 10c 7 into 1 by 2 to the 7 and 1 by 2 to the 3. You just calculate it and get the answer. Here 10c 7 is nothing but, we know that 10 factorial by 10 minus 7, 3 factorial into 7 factorial. So multiplied with 1 by 2 to the power 7, 1 by 2 to the power 7 into 1 by 2 to the power 3. You just solve it and get the answer. Okay, now we are going to go for another question here. Find the probability that, here first we have to do this question. 6 coins are tossed 6400 times. Find the approximate probability of getting 6 heads r times. Okay, so as I told here that when n will be so large, when n will be large and the probability will be very less, at that time we have to consider the Poisson distribution. Here you can see that the n is your how much? N is your 6400, and p will be how much? Probability of getting r heads, probability of getting 6 heads r times. First of all we are going to consider probability of getting 6 heads, how much. Okay, so here you can see that whenever the 6 coins, these are the 6 coins, 1 2 3 4 6 coins are going to toss to one time. If I am going to toss one time, what is the probability getting all the coins will be head and head. If I am going to toss one coin one time, then the probability of getting head equal to 1 by 2. So likewise for the 6 coins, it will be into 1 by 2, into 1 by 2, into 1 by 2, into 1 by 2, 5 into 1 by 2, that is your 1 by 2 to the power 6. So probability of getting 6 heads, tossing 6 coins at a time, will be 1 by 2 to the power 6. Or you can understand in this way that one coin is going to toss 6 times. One coin is going to toss 6 times. What is the probability that each time we are going to get head? 1 2 3 4 5 6. This is not. So 6 heads at a time in a row we are going to get. What is the probability? That is 1 by 2 to the power 6. Okay, so here the probability we found p equal to 1 by 2 to the power 6. It is very less. This is very less. Okay, and here n trial, how many trials? 6400. Trial is very high. If I am going to compare this one with this one, here probability is 0.5, n equal to 10. Here probability is 1 by 2 or 0.5 to the power 6. 1 by 2 to the power 6 is very less as compared with 1 by 2. And here n is 6400, very large as compared with this one. So if we are going to get this type of question, this question is going to go for the which distribution? Poisson distribution, right? So for Poisson distribution, this is the probability of mass function, that is your p of x equal to e to the power minus lambda into lambda to the power x by x factorial, right? So here lambda is your mean. So for the Poisson distribution, mean is nothing but n number of trials into probability, n into p, right? So here n into p will be how much? Here p for this case, this one, lambda equal to n into p. Okay, so this question's answer here write down, here this one, this is the answer belongs to this question. Okay, we are going to discuss, just wait. So these questions coin questions answer is here. The probability of getting 6 heads in a row of 6 coin for tossing one time. Okay, for tossing one time, like this you can write in your note, equal to like this, head, like this we are going to get. Okay, will be how much? 1 by 2, 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2 equal to 1 by 2 to the power 6. So probability is your 1 by 2 to the power 6, and lambda, that is your mean for Poisson distribution, equal to n into p. N is here 6400 into 1 by 2 to the power 6. So p of x equal to 6 means here, suppose r will be given that 6. Suppose 6 coins are tossed 6400 times. Find the approximate probability of getting 6 heads. R suppose given that 6 times. That means x equal to 6 will be e to the power minus lambda. Here you have to calculate the lambda, e to the power minus lambda into lambda to the power x. Suppose you have to put 6 by 6 factorial, right? Suppose x in your question, x given r times means it will lambda to the power r by r factorial. So for 0 time means lambda to the power 0 by 0 factorial. So for any time you can find out the answer. Okay, so here the basic difference between binomial distribution and Poisson distribution is that the probability is very less, should be very less, and the trial is very large. Okay, so we are going to go for the another question belongs to Poisson distribution. Here you can see, find the probability that there are 3 defects in a sample of 100 items if 2% of items in the factory are defective. So in the factory, how many items are there, we don't know, but it has been given that 2% of items are defective. So if we are going to consider 100 items, then 3 will be defective. What is the probability that it is asked in this question? Again I am repeat, see, 2% of items in the factory has been given that defective. Okay, if I am going to consider 100 items from that factory, the what is the probability? Find the probability that there are 3 defectives. Okay, 3 defects. So what is the probability? So here you can see that how many sample you considered. You considered the sample 100 samples. So 100 samples means 100 trials, n equal to 100, right? The probability has been given of defective items, probability given that 2%. That means 0.02 probability, right? So here you can see that n is so large, and probability is also less, 0.02. So this question is going to go for the Poisson distribution. Here I done the answer of this question, that p x equal to e to the power minus lambda into lambda to the power x by x factorial. As we know that lambda is the mean equal to n into p, and here n equal to 100. This is the lambda value here I calculated. 100 into 0.02. This is 02. Okay, 02 equal to 2. We found lambda value, and probability is your 0.02. This is 0.02. Okay, 0.02. So you just put that 3 is going to be defective will be e to the power minus 2, 2 to the 3 by 3 factorial, and you are going to get the answer. You just use your calculator, because calculator is allowed for you for your 5th semester. Okay, now here we concluded that whenever trial is large, as trials are large and probability of success is very less, or probability what we want is very less, for that case, for those questions we have to consider Poisson distribution. So I'm going to give you the limit one, somewhat limit, that here you can see that probability for the Poisson for the binomial distribution, you can get 0.3, 0.5, 0.1 like this. But in case of Poisson distribution, where we are going to use the Poisson distribution, when the probability of success will be 0.001 or 0.001, like this case, you are going to consider Poisson distribution. And for the trial, number of trial, in case of BD, binomial distribution, number of trial will be up to maximum 20 or 30. But whenever the number of trials will be more than 100, okay, more than 100, for this case you are going to use Poisson distribution. Just you have to remember this one. Okay, now we are going to go for another question, that this one, and both two questions are there, belongs to geometric distribution. Okay, this is one of the interesting, that I'm reading the question first, then we are going to discuss the answer. A soldier shoots a target in an independent fashion. Okay, suppose this is the target, and one soldier uh, firing independent fashion, to this target. Okay, as per the question, independent fashion, if the probability that the target is hit in any shoot is 0.7, so by any shoot this target is going to be hit, what is the probability given? 0.7. 0.7 is the probability that the target is going to be shoot by this soldier. Okay, what is the probability that the target will be hit on the 10th attempt? So here the 10th attempt is the first success of this soldier. Okay, you just imagine you are shooting the shooting this target, and uh, mm, uh, probability of shoot this target is your 0.7, and you attempted how many times? 10 times. 1 2 3 4 5 6 7 8 9 10. So the 10th one, this is the one, this is the first attempt, and this is your 10th attempt. Okay, the 10th attempt will be uh, strike this target. What is the probability? Okay, that means 10th attempt is your first success. You remember this one. Whenever you are going to get the question where you can found this type of perceiveness, that my my 10th attempt will be the first success. Okay, first success, where the question is indicates about the first success, that question will be go for the geometrical distribution. GD, geometrical distribution. You just remember, geometrical distribution is for the first success. Okay, so another question, here you can see that tossing the coin, get head on the 5th toss. I'm tossing the coin several times. So what will the probability that getting the head on the 5th toss? So 5th toss will be my first success, you can say. Okay, so for these type of question we have to use geometric distribution. So for geometric distribution, the PMF is your Px equal to x equal to q to the power x into p, this is into p, such that x will be 0 1 2 and so on, 0 otherwise. 0 otherwise. Okay, so this X indicates the number of failures preceding by the first success. So for this question, my first success is the 10th one. Okay, 10th is hits the target. The 10th attempt is my first success. Before that, how many times I have been failed? I have been failed 9 times, right? So 9 times I have been failed. Then 10th one is my success. Which one is my first success? Okay, so we have to solve this by using this PMF. Here you can see, it is in the question, it has been given that probability of hitting the target is your 0.7, so success is your 0.7 and failure is your 0.3, right? So P of X equal to 9. So as I told, this X is indicates the failures, number of failures preceding by first attempt. So for this question, how many numbers of failure? 9 numbers of failure. 9 times I have been failure. So X equal to 9. That means 10th one is my success. Okay, first success. So 0.3 to the power 9, because Q to the power 3. So if success is 0.3, so obviously failure will be 1 minus success is your 0.7. So failure Q will be 1 minus 0.7 is your 0.3. So here failure is your 0.3 to the power 9, because Q to the power X, right? And success will be 0.7 to the power 1, to the power 1. Okay, so to the power 1, you just calculate it and get the answer. Now for the second question, tossing the coin, getting head on the 5th toss. So if I am going to toss a coin, what is my probability of success? 1/2. Probability of failure 1/2. So on the 5th toss, I am going to get the head. So 5th toss I am going to be succeeded. So how many failures before that? 4 number of failures. So if I am going to use this one, this PMF, X equal to 4. This is 4 equal to 1/2 is my failure, probability of failure 1/2 to the power 4, and this is my success 1/2 to the power 1. Okay, you just calculate it and get the answer. Okay, now we are going to go for the another distribution, that is your negative binomial distribution. So here you can see there is a link between negative and geometric distribution. How it is, carefully you have to watch. Okay, first of all I am reading the question. Here is the 2 questions for negative binomial distribution. You just watch, then we are going to solve this. Okay, so here in the question it has been given that you can see, if the probability is 0.3 that a child exposed to a certain disease will contain it, that means the disease will happen for that child. If I am going to be expose one child to one particular disease, the disease will happen for that child will be probability is 0.4. So getting the or happening the disease, let that is your success. Okay, let the success is your getting the disease to that child. Okay, that is given that 0.4. What is the probability that 10th child has been exposed, 10th child exposed to the disease will be third to catch it, This is the important question. Several times you can see already asked in different exams, that one child, suppose one child has been exposed, this is your suppose this is the child has been exposed to a particular disease, suppose okay, the probability that this disease will happen to this child is your 0.4. Okay, now it has been it has been asked that what is the probability that 10th child, so one by one child has been exposed to this particular disease. So 10th child is exposed to this disease. what is the probability that the 10th one will be third child who gets that disease? That means if we are going to consider, if the whole story about this question, that means 10th children has been exposed to the disease and 3 children are affected. Okay, that means from the 10 children's, 3 children's are affected and 7 are not affected. Okay, if I will be consider affected is my success, so 10th one is my third success, right? Third success. So here you can see the soldier hits the target. The 10th one is the first success. Here the 10th one is the third success. So whenever you are going to get this type of question, that 10th one or some particular attempt will be your success belongs to number success, this here 10th attempt is third success. Okay, but here 10th attempt is the first success. So if it is first success, we are going to consider the geometric distribution. If it will be more than one success, we are going to consider negative binomial distribution, right? Now in this way we have to identify, that which question is belongs to which distribution. Then we are going to go for the probability mass function of that corresponding distribution, and we can solve that question easily. So here for the negative binomial distribution, you can see the mass function, probability mass function, P x equal to x plus r minus 1 c r minus 1 p to the power r minus 1 q to the power x into p. Okay, or here p to the power r minus 1. So p to the power 1, p to the power r minus 1, it will be p to the power r q to the power x. So x plus r minus 1 c r minus 1 c r minus 1 p to the power r q to the power x, 0 elsewhere. So this is the PMF of negative binomial distribution, and you have to remember that this is x belongs to number of failures preceding by rth success. So this is the r is belongs to the number of success. Okay, so for this question r is your 3. If r is your 3, the x is your obviously 7, right? X is obviously 7. So as we discussed that the disease is going to affect the child is considered as my success. Okay, so success probability already given, that 0.4, right? So P is always considered as success, Q is always considered as failure. So P already given in the question as 0.6. If it is 0.6, obviously Q will be 1 minus 0.4 will be equal to 0.6. So here it is given that the success is your 0.4. So success is 0.4. So the failure will be 1 minus 0.4 will be 0.6. Okay, so P value here, P value, Q value we found, and R is your value is nothing but number of success. Which numberth success? Here numberth success is your 3, and before that not before that, if I am going to exclude that number of success, I can found the number of failures. The number of failures is your belongs to 7. So if the total attempt is your 10th and the number of success is your 3, then number of failures obviously 7. So x will be 7. So you just put over here, that is x is your 7 plus r equal to 3 minus 1 c 3 minus 1 0.4 to the power 3, because 0.4 is belongs to success, to the power 3. How many children has been affected? 3, and affected we have been considered as success. So 0.4 to the power 3 into 0.6 to the power 7, q to the power x, that means 0.6 to the power 7. You just solve it and get the answer. Right, now we are going to go for the next question. You can easily identify these questions. This question is belongs to negative binomial distribution. See, in a company, 5% defective components produced. That one company produced 5% defective. How many numbers of production we do not know, but from that production we can get 5% defective. 5% defective, right? What is the probability that at least 5 components are to be examined? 5 components, at least 5 components examined. So I randomly I taken the 5 components and I examined. I found 3 defectives. Okay, I found 3 defectives. You just think that if I am going to consider the defective is belongs to defective is belongs to my success, that is belongs to P. What is the probability of P? Here it has been given 5%, that is 5 by 100, that is your 0.05. P has been given that 0.0. So obviously Q will be 1 minus 0.05 equal to 0.95. So we found P and Q. Here in this company, how many numbers of elements or items are produced? We do not know. We just going to examine the 5 components. So I choose this 1, 2, 3, 4, 5. I choose randomly. What is the probability that 3 is going to be defect? That means I choose the first one, not defect, not defect. Second one, defect. Third one, not defect. Fourth one, defect. Fifth one, also defect. So when I examined the 5, I got the 3 are defective. That means fifth one is my last defect. So I targeted that when I get the 3 defects, I have to stop my examination. So I one by one I am considered the items. First one not defective, second one defective, third one not defective, fourth one defective, fifth one defective. So I got the 3 defectives. So what is the probability for this one? That if I will be select the five number of items randomly, what will the probability that 3 are going to be defective? So here you can see, if I am going to consider defective item is my success. So 51 is my how many success? Third number of success. Okay, you understood. Initially I told that you just read the question carefully 2-3 times. You can easily understand that question is belongs to which distribution. So here we found that my defective is my success. If I am going to consider, then fifth one is my third success. So which type of distribution I can consider? I can consider negative binomial distribution, right? So so P is, here I done this answer. P is your 0.05, Q is your 0.95 as I written over here, and P of x equal to, that means getting 3 success, getting third number success is your fifth one. The fifth item is your third number success. Before that, how many not defective items are 2. So failures, the so-called failures will be x equal to 2. We are going to consider x equal to 2. That means for in this PMF we have to use x equal to 2, right? So you just use x equal to 2 will be equal to 2, what is x plus r minus 1. This one, you consider this one, x plus r minus 1, c r minus 1, 2 plus 3 minus 1, c 3 minus 1 into p to the power 3, q to the power 2. P is belongs to success. How many successes? That is your 3. Here considered success is belongs to defective, right? Okay, p to the power 3 into q to the power 2. So P is nothing but this one and Q is nothing but this one. You just put and solve it and get the answer. Okay. Now we are going to go for another type of question. Here this one. Suppose a bag contains 100 items. Okay, a bag contains 100 items, 5 of which are defective, 5 of which are defective, 10 items drawn without replacement for verification. Find what is the probability that among 10, 2 items are defective. Okay, the question is like this. In a bag, 100 items, 100 items, 100 items are there, 100 items are there, 5 of which are defective. Suppose 5 are defective, 5 are defective. 10 items are drawn without replacement. How many drawn? How many selected? 10. 10 numbers has been selected. Among the 10, 2 items are defective. Okay. So this is another type of question. So here, if you are going to compare this and this, this is very slightly different. Here you can see that this one, in a company 5% defective components produced, 5 component produced. That means here it is not given that how many numbers has been produced, but 5% defective data has been given. 5 components you are examined in order to 3 defective. Here in the bag 100 items are there, 5 of which are defective. Now 10 you are going to be considered, or 10 items are going to be selected. What is the probability that 2 items are defective? So here it is given in the form of percentage, but here it is not given in the form of percentage. Okay, from the 100 items 5 are defective, but here it is given the 5% defective. So this is a slight difference between these two questions. But after that, here 5 components are examined, 3 defective. Here 10 items are examined. Drawn means examined. 10 items are drawn, and for the verification or examination, you can found 2 defectives. So if I am going to compare this question and this question, here percentage has been given, here number has been given. From the total, how many numbers are defective? If it is so, then it will go for the hypergeometric distribution, right? So for the hypergeometric distribution, the PMF is your MCX, X is, this is your X, into N minus MC, N minus X whole divided by N capital N, C small n, and here X equal to 0, 1, 2, anything, and 0 elsewhere. The N capital N is belongs to total number. For this question, that will be 100, right? M is the less, the this one is the less than that of the N. Okay, belongs to defective, you can say. N is at most N. At most N means how many numbers we can select. We can select up to 100, right? So N is belongs to how many numbers of selection. So for this type of question, you just draw this figure. Okay, in detail we have been discussed hypergeometric distribution. You can found my playlist, and there also many questions we have been solved based on the hypergeometric distribution. This is one of the question here I am discussing. So here N is belongs to total number of items in the bag. N equal to 100. So how many defectives? M belongs to how many defectives? 5. So from the 100, how many you have been selected or randomly? That is 10. This is considered as small n. This is small n. Small n. How many you have been selected? 10. Okay. And from that 10, how many defective? That is belongs to x equal to 2. Okay, if x equal to 2, not defective will be n minus x. N minus x will be 8 for this question. And if 5 will be defective, not defective from the total, n minus m, capital N minus capital M equal to 95. Here n minus x, small n minus x will be 8. Okay, so all the values belongs to this PMF we have been found from this diagram. So I suggest that you just draw this diagram before you have to attempt this question. Okay, total has been given. Some from the total you can found number of items are defective, that is considered as capital M, and rest are considered as n minus m. How many numbers are we have been selected? We have been selected 10, considered as small n. From that 10, x equal to 2 numbers will be defective, right? That will be and n minus x will be 8. Just we have to put all the values in this PMF and we are going to get the answer. M is your how much? 5. 5c2. 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 Okay, 5cx means 5c2 into n minus m, capital N minus m will be 100 minus 95, sorry 100 minus 5, 100 minus 5, that is your n minus m, 95c n minus x equal to 8, 95c 8 divided by 100c 10, 100c 10. So you just calculate it, solve it, and you can get the answer. Okay, so here I suggest that what is the simple difference between negative and hypergeometric distribution, negative binomial and hypergeometric distribution. Similar type of question, here it is given that what is the percentage of defective. Here it is given that from the total how many numbers are defective, and here you have to remember that you dragged or you selected from the total how many numbers, how many 10 numbers without replacement. You are not replacing again. See, in this bag 100 items are there, you drawn one, again one, again one, like this 10. You are not drawing one and again replacing, you are not doing that, this one you are just drawing 10 one by one. Okay, if you are drawing one ball and replacing, if that type of case you can found, that will be belongs to your multinomial distribution. Multinomial distribution. About multinomial distribution and regarding numericals, I detail have been discussed. You can found from the playlist. But here I discuss here I am going to discuss one question. This one, okay, belongs to multinomial distribution. Question has been given that if a die tossed 4 times, one dice tossed 4 times, one die tossed 4 times, this is 1 2 3 like this on the face, you can get the 6 up to 6 numbers. It is rolled 4 times, 4 times. If one die is going to roll one time, then we can get 6 sample points. Okay, 6 sample points. If it will roll 2 times, one time, for 2 times it will be 6 to the power 2, 36 sample points. And here 4 times rolled means 6 to the power 4, that means 36 into 36 number of sample points we can get, in the sample space. But what is the question has been given, that here you can see 4 times it has been tossed or rolled. Find the probability that getting 1 time 1, okay, 1 time 1, 2 times 2, and 1 time 5. So if the die will be tossed 4 times, what is the probability we are going to get? That 1 time 1 will be come up on the face, 2 times 2's, 2 times 2's, and 1 time 5, like this. Okay, what is the probability? So here you can see that if a die is going to be tossed 4 times, uh, 4 times, so each time it can be so 1 or 2 or 3 or 4 or 5 or 6. Any number can be come up on the face. But here in the 4 times, whenever we are going to be rolled this dice, in the question it has been asked that 1 time it will be so 1, 2 times it will be so 2, and 1 time it will be so 5. What will be the probability? Okay. So if this type of question we are going to get, that will be go for the multinomial distribution. Multinomial distribution. For the multinomial distribution, this is the PMF, that is your P x1, x2, x3 up to xk equal to n factorial by x1 factorial into x2 factorial into xn factorial into p to the power x1, p2, p1 to the power x1, p2 to the power x2, px up to px to the power xk. What are the meaning of these symbols? I am going to be discussed. And about multinomial distribution we detail discussed. Okay, you can find the video in the playlist. Okay, here I am discussing the comparative comparison between all the distributions. So for this type of question we have to use the multinomial distribution, right? And here I discussed that if I am going to replace, not if I am going to replace the items also belongs to multinomial distribution, that question also I am going to discuss. Just wait. So here x1 plus x2 up to xn is your n. P1, P2, P3 up to Pk will be 1. These are belongs to all the probabilities. Okay. Belongs to x1, x2, xn. x1 plus x2 up to xn will be n. Represents the number of trials, you can say, number of trials. So here in this question, number of trials is 4 times. Okay. So as I told that probability of getting this one time 1, 2 time 2's, and 1 time 5, what is the probability? So whenever I am going to toss a single die, what is the probability of getting 1? 1 by 6, getting 2, 1 by 6, getting 3, 1 by 6, getting 4, 1 by 6, getting 5, 1 by 6, getting 6, 1 by 6. The probability of P1 here, P1 equal to 1 by 6, P2 1 by 6, P3 means probability of getting 3. This is probability of getting 3, right? Probability of getting 3, 1 by 6, probability of getting 4, that is a P4, 1 by 6, P5 1 by 6, P6 also 1 by 6, right? And n number of trials are 4. So here x1, x2 up to xn, x1 plus x2 up to xn is your n equal to 4, right? And if I am going to add all the probabilities, will be 1. Now here x1 is telling about belongs to occurrence of 1. Occurrence of 1. Occurrence of 1 is how much? 1. x1 is your 1. x2 occurrence or getting 2. Getting 2 how many times? 2 times. x2 equal to 2. x3. Is there any x3? x3 means number 3. Occurrence of 3 or getting 3 is 0. Getting 4, we don't have getting 4 in the question, so x4 is belongs to getting 4. x5 is getting 5, will be 1. x6 is getting 6, how much? 0. So here x1 is your 1, x2 is your 2, x3 0, x4 0, x5 1, x6 0. Now we are going to put all these values in this PMF n factorial, that means 4 factorial. Here you can see 4 factorial, that means we want to find out this one, P of x1, x2, x3 up to xk. P of x1 is your 1, x2 is your 2, this one, x3 0, x4 0, x5 1, x6 0, right? So it will be n factorial, 4 factorial divided by 1 factorial, 2 factorial, 0 factorial, 0 factorial, 1 factorial, 0 factorial into 1 by 6. See, P1 to the power x1. P1 is how much? 1 by 6. No. Yes or no? 1 by 6, 1 by 6 to the power 1. P2 to the power x2. 1 by 6 to the power x2 is your 2. 2. P3 to the power 0 because x3 is your 0. P4 to the power 0 because x4 is 0. P6 here, P6 up to pk means up to P6 we have to move. P5, I am telling P5 value is x5 is your 1. P5 to the power x5, then 1 by 6 to the power 1 because x5 is your 1, right? And for P6, that means P6 to the power x6 is 0, 0. Okay, so here you can see that if you are going to solve it, that is here 1 by 6 to the power 0, 1 by 6 to the power 0, 1 by 6 to the power 0, also 1. So here you can see 1 by 6 to the power 1, 1 by 6 to the power 2, 1 by 6 to the power 1. That means 1 by 6 to the power 4. And here if you are going to solve it, you are going to find it 12. 12 by 6 to the power 4 is the answer. Okay. Now another question I am going to discuss. This one belongs to binomial distribution. Multinomial distribution. Here you can see that in a bag 5 red balls, 4 blue balls, 6 green balls are there. So total number is 15. These questions already I have been discussed whenever I discussed in the multinomial distribution numericals. You can check the playlist. So a bag contains 5 red, 4 blue, 6 green balls. Find the probability when 5 balls are selected. I am going to select randomly 5 balls with replacement. With replacement. It is written with replacement means you have to use the multinomial distribution. And without replacement, if it is given that, you have to use the hypergeometric distribution. Okay, I suggest that belongs to hypergeometric and multinomial distribution, whatever we have been discussed in detail before that, you have to watch. Okay, so if 5 balls are selected without replacement and getting 2 reds, 2 blue and 1 green, what is the probability? Okay, so here red 5, 4 blue, green 6 balls are there. I am going to draw 5 balls. 2 will be belongs to red, 2 will be belongs to blue, 1 will be belongs to green. Okay, so here total number of balls in the bag is your 15. Number of observations, how many? 5. 5 is the number of observations. X1 is your 2, x2 is your 3, x3 is your 1. By multinomial distribution, probability of 2 to 1. 2 to 1 is your n factorial, as I told here, n factorial by x1 factorial, x2 factorial up to xn factorial. This is your xk, sorry, this is your xk. I mistakenly written xk factorial. Okay, xk factorial. So x1 is 2 factorial, 2 factorial, 1 factorial, 5 factorial by 2 factorial, 2 factorial to 1 factorial. And the probability of P1, here you can see probability of P1, that means from the 15 balls, if I am going to consider red ball, considering if I am going to draw 1 red ball, what is the probability? Probability will be 5 by 15. By drawing 1 ball belongs to red will be 5 by 15. For the red ball, the probability is 5 by 15. For blue is 4 by 15. For green, it is 6 by 15. So P1, P2, P3 I got. I just substituted over here, and corresponding x1, x2, x3 will be the power, and you just solve it and we are going to get this is the probability. Okay, so here I concludes I'm going to conclude all the distributions with the first discussion. Here you can see, if simply it has been given like this, probability is we are going to find out the simple probability. So we are going to use binomial distribution. If uh, the probability is very small and trial will be very large, we are going to use Poisson distribution. And if we are going to found that we are going to find out the probability for the success will be first time, belongs to geometrical distribution. For some rth time of success, I considered 10 times, and belongs to 10 time, in between 10 times, or 10th one is my some success, that may be third, that may be four success, then that type of question will be solved using negative binomial distribution. Hypergeometric distribution, I told that by considering, here you can see that number of total number of items and total number of defects will be there, but here it will give you the probability, percentage or probability already given. Then we are going to go for the negative binomial distribution. For hypergeometric means number of items will be given and corresponding number of defects will be there. And suppose in the question it has been written that without replacement one word, that means hypergeometric distribution. And with replacement word, if this type of question is going to be asked, it will be multinomial distribution. And multinomial distribution, another question also here I discussed. So I hope with this video you can judge that which question which belongs to solve by which distribution in your exam. May this video will be help you for your exam. So thank you so much for watching this video. Thank you.